Hi, my name is Nur Sakina Hani. I'll explain about the result in question 1 and question 2. In question 1, we put the value in the equation in gain function and we change into transfer function. So we got this value. In question 2, by using Scilab, we use both plot technique to show the amplitude response and phase response. From this Scilab, the gain crossover frequency, phase crossover frequency, gain margin, and phase margin showed. This is the coding for the gain crossover frequency, phase crossover frequency, gain margin, and phase margin. So after we put the coding, we got the both plot graph for magnitude response and phase response. And we got the value for gain margin is negative 7.96, phase margin is 1 to 7.58, gain crossover frequency is 1.75, phase crossover frequency equal to 0.
My name is Faziza binti Mak Yasa. My matrix number is 2010111124. I will explain about question number 3, which is about use lead compensator to further improve 10% of current phase margin of response. So, we must know the phase margin, which is 1 to 7.58 degree and gain crossover frequency 1.75 degree. We use this formula and plus with 15 degree, then the phase margin must multiply with 110%, so we can get 140.34 degree. Then 140.34 degree subtract with the phase margin and plus with 15 degree. So we calculate until get 27.76 into this sign. We calculate until we get the alpha value. Next, for code, phase margin and gain crossover frequency, we sub transfer function into this coding and value from GCS 1.655 and 1.604. This is our dot plot for phase margin and gain crossover frequency. And this is our Scilab code response lead compensator. This is our graph for lead compensator. So for this steady state error, we assume the value until get less than 1.01. It satisfies first requirement. This new value that we get from the Scilab code will take out the phase margin and gain crossover frequency value. So this is the new value.
Assalamualaikum and good afternoon. My name is Anishara binti Zamri and my message number is 20101257 and 76. So for my part, let compensator to increase 10%. So from previous phase margin 1 to 7 0.58, we need to find new paste margin. So for new paste margin, 127.58 times with 110%. So we got 140.34 times plus with 5 degree, and we need to find the new value for paste frequency. So we need to minus 180 plus 145.34. We got negative 4.68. So this is our graph board plot for lag compensator in magnitude and phase response. Next, we need to find for reduction of gain, that is 20 log alpha. So we need to find for alpha first, and we find the value from omega from the board plot base, and we put in 20 log alpha, and alpha we got 1.101, and this is the value to put for the new GS. So this is a new GS, and you put this in your console Scilab, and this is what we got for lag compensator. Then this is graph for RAM response for lag compensator, and so we need to find the steady state error. So we need to find the steady state error more than 0.10. So we take x minus y 0.22 minus negative 11.23 to certify that this is the second requirement. This is the 10% improvement for paste margin for lag compensator. So this is a new our paste margin and gain GCF. This is 127.06 and GCF 1.742.